Lesson 12.5, Binomial Theorem. This should go on page 41 in your notebook. The binomial theorem is a way that allows us to multiply out two terms to a specific power. So when you have two terms like so, an a plus b to the 0 power, anything to the 0 power is 1. A plus b to the 1 power should be itself, so the answer should be a plus b. When you square it, you get a squared plus 2ab plus b squared. Hence, these are the coefficients of the numbers that you get when you multiply everything out. When you multiply out to the 3rd power, 4th power, 5th power, 6th power, this Pascal's triangle allows you to figure out the coefficients of your term. This is the first step to multiplying out all the terms. There are a few more steps after, of course. So Pascal's triangle can be created very simply with 3 ones. Then you take the 2 middle ones, add them up, that's your next term. All the outside numbers are 1s, and then you get 1 plus 2 equals 3, 2 plus 1 equals 3, 1 plus 3 equals 4, 3 plus 3 equals 6, so on and so forth. This one has up to the 7th power, this one has up to the 6th power. Of course, you can make your chart go to any power you want, but as you can see, this grows fairly fast, and most of the time we don't do anything higher than the 6th power. Here are the steps to how to multiply out a binomial. Number 1, use Pascal's triangle to write down the coefficients. Then the first term decreases in power from the left, while the second term decreases in power from the right. Simplify each term. Remember to multiply out the exponents first. So let's see how it's done with the first one. First one says 2x plus y to the 4th power. When it's to the 4th power, the coefficients follows 1, 4, 6, 4, 1. I would suggest that you give yourself a lot of space when you're writing this out. So I would write 1, 4, 6, 4, 1. Next, determine the left term. The left term is 2x. You take 2x and you start it with the highest power. So 2x to the 4th. Then it decreases in power. 2x to the 3rd. 2x squared. 2x to the 1. You don't necessarily have to write the last one because it's to the 0 power. Also, watch out for the fact that I am putting parentheses around the entire term. So remember that the exponent applies to the entire term and not just to the variable. The second term in my binomial is the y. So I start from the right-hand side and I decrease in power. Y to the 4th. Since y is a single term, I don't need the parentheses. So y to the 3rd, y squared, y to the 1, and no y on the last one. The key is that every single term in between is addition. So we're adding all the terms together. Last but not least, now using your rules of order of operation, make sure you simplify each term and add them up. The first term is 2 to the 4th times x to the 4th and times 1. 2 to the 4th is 16, so 16x to the 4th. That would be my first term. Plus 2 to the 3rd is 8. 8 times 4 is 32. 32x to the 3rd, y to the 1st power. Plus 2 squared is 4. 4 times 6 is 24. 24 x squared, y squared. Plus 2 to the 1 is 2, times 4 is 8, 8x, y to the 3rd, and the last term plus y to the 4th. And this is the final product, okay? Now, there are some differences when you have a subtraction in your binomial, and also when there's a power to a power, so watch out for those. So let's try the second example. This time it's to the 5th power. So because it's to the 5th power, I look up at the Pascal's triangle and see that my coefficients are now 1, 5, 10, 10, 5, 1. So I put 1, 5, 10, 10, 5, 1. Space them out, giving yourself plenty of space to show every single term. All right, my left term is x squared. So it is x squared to the 5th. Make sure the 5th is on the outside of your parentheses. Decrease in power, x squared to the 4th, x squared to the 3rd, x squared squared, x squared to the 1st, and no more on the last one. All right, repeating the same idea as before. Now I take my right term, negative 3y. The negative follows the 3y, so it goes negative 3y to the 5th, negative 3y to the 4th, negative 3y to the 3rd, negative 3y squared, negative 3y to the 1st. Don't forget, the operation is plus in between all of these terms. A nice, very, very nice separation for them. Okay, let's clean up. This is x squared to the 5th. A power to a power multiplies. So first term is x to the 10th. Next, you have negative 3 to the first power times 5, hence making this negative 15. X squared to the 4th, 2 times 4 is 8, x to the 8th. And then y to a single power, so single y. Next, negative 3 squared makes it positive 9. 9 times 10 is 90. And then x squared to the 3rd, so x to the 6th, y squared. Next, you have negative 3 cubed. So negative 3 cubed is negative 27 times 10, negative 270, x to the 4th, y cubed. Then you have negative 3 to the 4th, excuse me, making it positive 81. 81 times 5, 405. So positive 405, x squared, y to the 4th. And last but not least, you have negative 3 to the 5th. That's negative. 3 to the 5th is 243. So 243, y to the 5th. So one thing you have to watch out for is when there's a negative, notice that your signs alternate. Positive, negative, positive, negative, positive, negative until the end. Whereas if it's plus, it just pluses all the way. Okay? All right. A quick reminder on the combinations. So combinations is going to show you how we can get some of these terms that we use Pascal's triangle to multiply out. How can we get specific terms with a shorter route? So combinations is one of the formulas we use to help us out. So it's just a quick reminder that when you see n over j, the first number over the second number is n factorial over j factorial and the difference factorial. So here's a quick exercise. 8 choose 6, this is the way we read it, is really 8 factorial over 6 factorial. The difference between these is 2, so 2 factorial. Now reminding yourself, what is 8 factorial really? 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So when you expand that out, 8, 7, 6, 5, 4, 3, 2, 1. Most people actually don't expand it out, but we're going to expand it out to show you how you can cancel some of these. Right? If you remember how to do this from past years, then you can go ahead and use a shortcut. The first one has 6 factorial, so 6, 5, 4, 3, 2, 1. You will notice that these are all the same. So yes, these can all be canceled out. But don't forget you have a 2 factorial, so 2 times 1 here. So what I would do is I would cancel out 6, 5, 4, 3, 2, 1. And then use this 2 to reduce out this 8 to be 4. So really my final answer would be 4 times 7 all over 1, which makes this 28. Okay, so it's a reminder of how to do this using combinations. Okay, so why does this help us? Well, when we have a bigger exponent, when we have a bigger expansion, for example, like this to the 10th term, to the 10th power, we really don't want to multiply everything out. Sometimes we want a very specific term. So this is where you have to kind of jump in and figure out what is being asked of you. You need 4 pieces of information. You know what n is, you know what j is, what a is, and what b is. All right. So a and b are the very easy things to spot. A is the left term, b is the right term. So that's the first thing I'm going to do. I'm going to remind myself that a is the left term, so a is 2x, and b is negative 3. All right. And then I look at this and say, all right, well, I want the coefficient of x to the 3rd. I'm going to pause on that real quick. N is the power that is being taken to. So n is 10. Now the question is, which term am I looking at? X is the first term, so I want x to the 3rd. If x is to the 3rd, there's a trick that these two exponents should add up to the right total. So if I want x to the 3rd, that means the first term is to the 3rd power, the second term should be taken to the 7th power because 3 plus 7 needs to add up to 10. So these two numbers need to add up to n. So since x is the first term, a corresponds to x. So a needs to be taken to the third power. That means my b needs to be taken to the 7th power. So in this case then, j is 7. All right. Now I have everything. I can put everything into the formula. So formula says n of, n minus j. So n on top. N minus j is 3 because 10 minus 7. And then I want 2x taken to the n minus j power, which is the third power. And then b to the j power, which is 7. Notice that these two add up to be 10. So they add up to the total power. So now I can work this out and figure out this specific term without having to expand this out. So the work now is 10 choose 3. So 10 factorial over 3 factorial. The difference between these is 7 factorial. I'm going to work this out first and then multiply the rest out later. So 10 factorial is really 10 times 9 times 8 times 7 factorial, because 7, 6, 5, 4, 3, 2, 1. All over 3 factorial is 3 times 2 times 1. And then you have another 7 factorial. This is the shortcut I was referring to. Notice you can just go ahead and cancel out the 7 factorial without worrying too much about it. And now I'm going to use the denominator to cancel more stuff on top. Generally, when you're using this formula, you should get 1 on the bottom. You should always be able to cancel out everything on the bottom. So 2 goes into 8 4 times, 3 goes into 9 3 times. So all in all, this problem becomes 3 times 4 times 10. That's 120. Now going back to my formula, what does this term look like? What does the coefficient of this term look like? I have 120 times 2 to the third power, that's 8, x to the third. All right, negative 3 to the 7th is negative 2,166. Taking the three coefficients, multiplying them out, gives you a grand total of 2,080,320 x to the third. So there you go. There's a coefficient of our term. So this is our answer. All right. We're going to do a very similar thing to the next one. So the difference is this time it doesn't tell you what the x power is, but it tells you it's a fourth term. So you kind of have to use your knowledge of the Pascal's triangle to help you simplify down what the j term is. So the first three things are still very obvious. N is the power, so n is 9. Our left term is 3x, so a is 3x. And our right term is negative 2. b is negative 2. So again, the hardest part is j. What is j? Is j 4? No, j is not 4. When you're looking at the fourth term, that means the very first term got taken to the 9th power. So you got to count down and count 4 from the first term. So the first term is 9th power, 8th power, 7th power, 6th power. So the 6th power is what you want to look at. So m minus j must be 6, so that means j is 3. Because the first term is my x terms, and if the x term needs to be a 6th power, the other one must be the 3rd power. So now, using that same idea, we're going to plug it into our formula and see that this is really 9. And then the bottom is n minus j. 9 minus 3 is 6, so 9 choose 6. And then my first term of 3x taken to the n minus j power, so n minus j, 9 minus 3 is 6. And then my second term, negative 2, gets taken to the 3rd power. All right, same as before, we're going to work out the combination factorial first. So it's 9 factorial over 6 factorial. 9 minus 6 is 3 factorial. All right, using the same shortcut, 9 times 8 times 7 times 6, 5, 4, 3, 2, 1, all over. I'm going to line up the 6 factorial right underneath so I don't miss that. And then 3 factorial is 3 times 2 times 1. So same as before, I can get rid of the 6 factorial and go gone, gone. And I can go 2 goes into 8 4 times, 3 goes into 9 3 times. 3 times 4 times 7, that will give me a grand total of 84. Now, I have 84 times 3 to the 6. Sorry, 3 to the 6 is 9 times 9 times 9. So that's 81 times 9. That will give me 729. X to the 6. Negative 2 to the 3rd, that's negative 8. If we take 84 times 729 times negative 8, we will get negative 489,888 x to the 6. So what's different this time is it wants the entire term, so we will box our whole answer. Okay, so the notes today should be able to help you with the homework and the worksheet that will be for tomorrow. So the homework for tonight goes on page 42, and the worksheet will go on, will be your in-class assignment for Friday. And don't forget to turn it in at the end of the period. Okay.